This is the solution video for the puzzle family constellation, an intermediate puzzle published on July the 25th of 2024. And it features two equilateral triangles placed on a line and sharing a vertex over here. And there are drawn two line segments connecting vertices like this, and a line segment connecting midpoints like this. And we are asked to prove that this smaller blue rectangle is also equilateral. And the approach is very elegant. It's from Mr. Matthew Arcus, and I'm gonna take that approach, obviously. Well, first of all, if I visualize the points, the basic point is that if you draw the triangle BCD and you compare it with the triangle BFG, well, what you first can see is that if you carefully look at the top angle, this is 30 degrees, this is 30 degrees, and there's this 60 degrees, so that's 120, and this is also 120. So you know that, well, let me prove that for you. So this angle is 120, and this angle is also 120. So you know that those angles are the same. Yeah. But also, this, let's say that this has length A, then this has length A times half square root of 3. And if this has length B, then this is B times half square root of 3. So they have the same proportion, and using those two facts, so the equal angle and the same proportion, we know that the two triangles must be similar. And that means that these angles are the same. So let's say this is angle X. Then the angle X is also over here. But then you can see that those 4 points, B, H, C, F, must be on a surface. They must be cyclic. So let me prove that for you. Those 4 points are indeed on a circle. And that's from the equal angle and this chord subtends then the equal angle, so they are cyclic. So now we use that circle to show that this angle, so FHB, is equal to FCB, which is 60 degrees. So we have just found that this angle is 60 degrees. Well, you can do exactly the same on the right hand side. You can show with again that these 4 points are cyclic, using exactly also two similar triangles, which I leave to the viewer. And then you know that this angle is that angle, which is also 60 degrees. So we have also that we have here an angle of 60 degrees. And therefore we know that the remaining angle of the blue triangle is also 60 degrees. So we have thus proven that the blue triangle is equilateral. And note that if the two original equilateral triangles were not on a line, so if this wasn't 60 degrees but some other angle, then the proof still holds. Yeah, because then the equality of those angles is still there. It is 60 degrees plus the angle between them, and that's the same. So this can be generalized to the two equilateral triangles not being on a line but having any angle between them. And I thank Mr. Matthew Arcus for this insight. Okay, and that completes the proof of the puzzle, a family constellation.